Now you may be wondering, what happens if we have more data columns, so not just tests and grades, but maybe something else like the ranking of the student in the class? How do we fit 3 columns of data? Well, the only difference is that now we won't be working in 2 dimensions, we'll be working in 3. So now we have 3 axes, x1 for the test, x2 for the grades, and x3 for the class ranking. And our data will look like this, like a bunch of blue and red points flying around in 3D. And our equation won't be a line in 2 dimensions, but a plane in 3 dimensions, with a similar equation as before. Now the equation will be w1x1 plus w2x2 plus w3x3 plus b equals 0, which will separate the space into 2 regions. This equation can still be abbreviated by wx plus b equals 0, except our vectors will now have 3 entries instead of 2. And our prediction will still be y hat equals 1 if wx plus b is greater than or equal to 0, and 0 if wx plus b is less than 0. And what if we have many columns, like say n of them? Well, it's the same thing. Now our data just lives in n-dimensional space. Now, I have trouble picturing things in more than 3 dimensions, but if we can imagine that the points are just things with n coordinates called x1, x2, x3, all the way up to xn, with our labels being y, then our boundary is just an n-1 dimensional hyperplane, which is the high dimensional equivalent of a line in 2D or a plane in 3D. And the equation of this n-1 dimensional hyperplane is going to be w1x1 plus w2x2 plus all the way to wnxn plus b equals 0, which we can still abbreviate to wx plus b equals 0, where our vectors now have n entries. And our prediction is still the same as before. It is y hat equals 1 if wx plus b is greater than or equal to 0, and y hat equals 0 if wx plus b is less than 0.